Part 2 of 3.6 notes pre-calculus. Here we go. So I did a ton of explaining on number 2. I'm not going to do all that domain range thing from here on out, unless it warrants it. So y equals 7 minus 9x is the function we're dealing with right here. It's a basic swap out the x's with the y's, get y by itself. So this is now x equals 7 minus 9y. You know what? The easiest way to work with this is I'm going to add the 9y over here and then subtract the x to the left. That basically takes away like the clunkiness of negatives in front of the y because I'm ultimately going to divide by 9. So 9y equals 7 minus 1x. Divide both sides by 9. And the way I'm looking at this is negative 1/9 x plus 7/9. This is a linear equation that starts at 7/9 on the y-axis and then moves down 1 for every 9 units left or right. So down 1, right 9. It's a linear equation, which it's pretty standard that those have negative infinity to infinity, unless it's like a special case for its range, and then negative infinity to infinity for its domain as well. So g inverse of x equals negative 1/9 x plus 7 over 9, whose domain is negative infinity to infinity. Right, and I've been keeping a tally over here of my inverses because I think I might need to use them later on. So I've got f inverse right here. G inverse is going to be negative 1/9 x plus 7/9. Let's move to number 4. So for k of x, I see root x. Swap out the x's and y's. Get rid of the root by squaring both sides. X squared is equal to y, which is the same thing as k inverse of x is equal to x squared. Now here's the tricky part. The tricky part to this is when I look at my original function, root x, its graph follows this pattern. X squared looks like this. It looks like my original drawing that I put on that other side of the board. Notice, though, x squared isn't a half parabola. X squared is a whole parabola. But having a whole parabola makes it no longer 1-to-1, which means the whole parabola does not have an inverse. So what you have to do here is you have to say, hold on, this does not belong here. Root x had a domain of 0 to infinity. The range of root x is going to be 0 to infinity. So when I get x squared as my inverse, I instantly have to restrict the domain to match the range of the original function. I instantly have to say, k inverse of x equals x squared, but only if, very specifically here, x has to be greater than or equal to 0 because it matches the range of the original. Where x is greater than or equal to 0, you could have written it in interval notation. Usually it's written like this, though. So there we go. Number 4 conquered, and you can see kind of similarly on number 5. Oh, I should probably keep my tally here, right? And I got to be clear about the fact that this is only a half parabola. All right, what do we got? Number 5. I'm going to make an adjustment here because I think it would be, I don't want to do just a straight up repeat concept of what I'm seeing here. So instead of x is greater than or equal to 0, I'm going to say, what would it be if x is less than or equal to 0? So nothing really changes from the start here. You're replacing the h of x with the y value. Switch out the x's and the y's. I'm going to add the y squared to, get rid of that whole negative y business. Subtract the x. Cancel, cancel. Y squared is equal to 1 minus x. Square root both sides. Now, if you square root both sides and you got variables involved, you're supposed to say, well, it could be plus and it could be minus. But here's the deal. My original function, its domain was restricted to less than or equal to 0. So this would be shifted up 1, and it's a downward parabola. That essentially looks like this. Less than or equal to 0 is that way. Now, when I see this right here, to get a better perspective, I could factor the negative out of the x, which creates x minus 1 inside. So that's a parabola. No, not a parabola. A square root function that's shifted right 1 unit, and then it's going to be horizontally reflected. Okay, it's instead of going that way, it's going to move this way. So the question is, it's got to reflect over this imaginary line. So does my half parabola, my square root function, need to go under the x-axis or above the x-axis? It needs to go under. Like that. And it makes perfect sense when you start to think of the swapping of the x and the y values. 0, 1 becomes 1, 0. Negative 1, 0 becomes 0, negative 1. It has to go below. So you would have to say keep the minus, because the plus does not yield the right square root function. You'd have to go above the x-axis for the plus here. So, I don't know. Hopefully that makes sense to you guys. You just keep one of these. That's a legitimate way of writing the inverse as well. And I should probably say this is H inverse. The domain of that would be negative infinity to 1. And yeah, that'd be H inverse. You know what? I think whatever we're doing over here, the 1 minus x is going to be a lot easier to work with. Yeah. Keep it 1 minus x. All right, and then what I do is I throw some function composition in there. So this might end up being a longer video. Please be patient with it. Let's see, we go all the way up to number 8. Yeah, just through 8. So we got 4 more. So how do we deal with function composition and inverses? Well, since we've got all of our inverse functions, it's basically just a review of what we talked about with function composition. So what I mean by that is, we know that this notation is the same as f inverse of g of x. Just like that. The g function was, hold on, I don't have them in front of me right now, so I should probably scroll back up for my own viewing. What was it? So g of x was 7 minus 9x. So you're plugging 7 minus 9x into x over 2x plus 1. So you're going to put 7 minus 9x on top, and then 2 times 7 minus 9x on the bottom, plus 1. At this point, your job is just to simplify and try to find the domain. So the bottom looks like you've got 14 plus 1 would be 15. And then the 2 times negative 9x would be minus 18x. So this is your function that was composed of those other two. At this point, you just think to yourself, okay, for domain, is there an issue with the function I input into this? Which there's no issue because it's a polynomial, okay? It's a linear equation. So no input problem. And the output seems like my bottom fraction, you can't have that equaling 0. So you'd set 15 minus 18x equal to 0. And that's the only domain problem. So it's going to be all real numbers except x can't equal. This turns out to be 5 over 6. And that's it. All right, let's check out number 6. Number 6, we're doing the exact same thing, f inverse of g inverse of x. We've got our f inverse function. We've got our g inverse function. Remember, the function we're plugging into has 2 times the input function plus 1 on the bottom, and then the top is the input function. So negative 1/9 x plus 7/9 is g inverse. So I'm putting that in place of the x on top and the x on the bottom. All right, now you guys can do you take the long way by just finding a common denominator on top, finding the common denominator on the bottom, rewriting it so it's horizontal. If you've never seen this before, maybe check out this strategy. I see nothing but 9s on both the bottom and top for my fractions. So here's what I'm going to do. If I multiply the top by 9, I instantly get rid of those 2 9s on the bottom. It's going to be negative 1x plus 7. But if I multiply the top by 9, I got to do it to the bottom as well. Now here's where we can get creative. You take the 9 times the 1, you get plus 9. This 9, when taken times this block of multiplication, can be distributed before the 2 can. I can distribute that 9 inside the parentheses, but just not give it to the 2. So you put 2 on the outside, it's going to be negative 1x plus 7 on the inside. Yeah, and you know what? If that didn't make sense, just go ahead and go back and do it the common denominator route. It takes a little bit longer, but I don't know. This seems like it's it gets us to the final answer quicker. But make sure it gets us to the right final answer, you know? So 2 times negative 1x is negative 2x. And then you've got 2 times 7, which is 14. 14 plus 9. 23. So there's my composite function. My input function has an all reals domain situation, so there's no issues there. But this one, yeah, the bottom can't be 0. So it's a pretty simple negative infinity to wherever the bottom equals 0. It ends up being positive 11.5. With a parenthesis because it literally cannot equal 11.5. And then 11.5 to infinity. All right, last two. Nothing much different from what we've seen already. I'll let you guys try this one on your own. Pause it. Okay, let's see if you're correct. H inverse of f of x. Plug in the... Here's my inverse function. H is the negative square root of 1 minus the entire f of x function, which turns out to be x over 1 minus 2x. So this is my composite function. What I'm going to do first, though, is find a common denominator, make it rational inside the root. So I'm going to put the 1 divided by 1, find a common denominator between those two. I need a 1 minus 2x on both the top and bottom to gel with this one. If we did some off to the side work, 1 times 1 is 1. 1 times negative 2x, negative 2x. Subtracting x. All of that divided by 1 minus 2x. So here's what we got. Negative root 1 minus 3x over 1 minus 2x. So here's my composite function. I'm keeping in mind right away that the input function had a problem at a half, but my output function still has a problem at a half, so I'm not going to worry too much about it. My domain states that the inside of the root must be non-negative. It's got to be greater than or equal to 0. So that's what I'm going to do. I'm going to set my inside 1 minus 3x over 1 minus 2x greater than or equal to 0. And this is where you have to go back to either, we talked about it in chapter 1, but we've talked about it extensively now too. Critical numbers to test intervals. So the top equaling 0 is x equals a third. That's my bracketed value. The bottom equaling 0 is x equals a half. That's my parenthesized values. You set up the intervals from negative infinity to 1/3. 1/3 is smaller than a half. And then go 1/3 to make a pit stop at a half. Put parenthesis there because it can't equal because it's on the bottom. By the way, it's bracketed because of the equal to right there, and it's on top. It's a 0 critical number. Yeah. So now, pick some points in between. This would be 0. A third is 0.3 repeating. A half is 0.5, so maybe 0.4. That's 2/5. You could plug that in. And then maybe 1 over there. Long story short, this gives you a positive divided by a positive, which is positive. This gives you a negative divided by a negative, which is negative. This one gives you a negative divided by a positive, which is negative. You're looking for greater than or equal to 0, so this one is out. Therefore, your domain of this new function is negative infinity to 1/3 in union with 1/2 to infinity. There's your domain of the function in red right there. All right, and then the last one. What happens if we do the composite function and then take the inverse of the whole thing? Well, you just got to take steps. Find this composite function first. You're plugging in 1 minus x squared, keeping in mind that h is set greater than, not h, x is set greater than or equal to 0. That's your domain, right off the bat. This must be true. And our g value is just a generic polynomial. 7 minus 9x. So we get 7 minus 9, negative plus 9x squared. So g of h of x is negative 2 plus 9x squared. We could maybe call that the function y equals 9x squared minus 2. Keeping in mind that x is greater than or equal to 0. But we've been tasked with finding the inverse of that function. The inverse of that function, switch the x and the y. And then get y by itself. Add 2 to both sides. Divide by 9. Square root both sides. Remember, we've got a plus or minus. The square root of 9 is 3, and then you can keep the top as is. Here's the deal. You know that it's got to be the positive version of this because x is greater than or equal to 0 was the original parabola. So you were looking at 9x squared minus 2, and it looked like this. Therefore, you're going to have a parabola that shifted left 2 that looks like this. So it's got to be the positive version of it to be above the x-axis. Yeah, and then final answer? Well, the domain of the original is the range of the inverse. The way I'm looking at it now is it shifted left 2. That's just going to be the only restriction. Left 2 units and then everything to the right of that. So this is my total final function with a domain of the inside greater than or equal to 0. Yeah, that's my domain of my inverse. Whew, okay. Guys, 23 minutes. That was the longest video I probably produced for you guys. Filmed. So thank you for staying for the whole thing. And yeah, hopefully it was helpful.